Let's talk about typical requirements and design considerations. So for requirements, of course, as with any subsystem, you want to think about size, weight, and power. You also want to make sure that the link closes. You want to think about the total data downlink that we talked about earlier, which has to do with data rate and contact time. You want to think about the amount of compression loss you can handle for your data, such that you still fulfill your mission and you have enough quality data. You want to think about signal noise. Will your signal noise dominate the amount of actual desirable signal you want to transmit and receive? And you also might want to think about directionality of your antennas, depending on your power requirements. Typically, directional antennas will give you much better gain properties. But then you have to think about your ADCS system actually pointing towards wherever you're transmitting. So let's see. Let's think about how these requirements can affect the other subsystems. So size, weight, and power clearly affects the structures subsystem and the power subsystem. A link budget that closes, we've talked about how power can affect the link. So you'll have to coordinate with the power lead. There are also thermal losses associated with the spacecraft. So there'll be coordination between the comms lead and the thermal lead to make sure that your equipment is cool enough, because I think it's warmer temperatures that add more noise. What else? Oh, the total data downlink. The communication sub lead will have to talk to the command and data handling subsystem lead, because the CDH lead is the one that coordinates the algorithms and the coding and the communication protocols, which has some bounds on data rate. The CDH lead also helps with the compression loss and signal noise. And then the ADCS lead definitely has to know if you're putting a directional antenna on your spacecraft or not. Yeah, so there was a question about, does the ADCS subsystem also need to accommodate this when figuring out their pointing maneuver? Definitely, for sure. Not only do they need to know if it's directional, they also need to know the precision necessary for that antenna gain profile. You'll see later on that antennas have a gain profile where straight on there's a certain intensity of power associated with the signal, but it drops off as the pointing is less precise as you go further away from that exact bore sight angle. So yeah, the ADCS subsystem also needs to know how precise you need to be to get an intense signal transmitted. High-level requirements contribute to data rate. Is this why we can't automatically assume that we will be able to download our data at our proposed times at mission concept? Yes, absolutely. You cannot take these communication links for granted, because there is a lot of thought and engineering work that's associated with getting as much data as possible. The pros and cons of maybe transmitting more data, but at a noisier level or with less redundancy. So if something wrong happens, then you'll lose the whole packet. So there's a lot of thought behind why we can't automatically assume that we'll download data. Yeah. Okay, there are external requirements associated with communications, not as much as power, but there are specific requirements. So let's look at the nanoracks IDD. So in the deployment switches, we talked about how radio frequency and transmission cannot be within the first 30 minutes after the switch is closed. It has to be only switched on after the first 30 minutes. For the CubeSat design spec, there are requirements about operators obtaining the proper licenses. Further, for amateur frequency use, this requires a proof of frequency coordination by the IARU. CubeSat shall comply with their country's radio license agreements and restrictions, where our country, the institution is called FCC. And you also need to refer to the ITU to determine what licenses and approvals are needed for their country. For the Artemis CubeSat, we have these requirements. We're restricting our comm systems to just work within LEO. And here you'll see transmit, but not necessarily receive. So receive is an augmented capability of the CubeSat kit. This is more so a one-way direction that we require. We don't require the uplink. We also have designed in our system the amateur radio frequency. Our ground stations shall receive UHF and process true telemetry, and the link budget shall have a margin of at least 5 decibels. Some constraints on our system. So some of these will look like the requirements, but I'm thinking about constraints as externally imposed rules or guidelines from other sources. So we have size, weight, and power that the structures and power subsystem leads will impose on the communication subsystem. There is some negotiation with that, but at some point you can't push back. There are atmospheric losses that you just cannot control for, and you just have to design around. So here there's a picture of the kind of atmospheric absorption percentages throughout the electromagnetic spectrum. Yeah, so these you can't really control. They are just what they are, and you'll have to build that into the link budget. And then other constraints are access to ground stations. Like we talked about, there are finite a number of ground stations. You have a finite amount of budget to work with, so only a certain amount of time on those ground stations if you decide to pay for them. So you'll have to work around that. There are questions about how many ground stations do satellites typically make contact with? And so that's really tough because there are so many different missions, so many different satellites, so many different networks. So all those permutations, it's really hard to say what the typical is. But for example, deep space missions will communicate with the deep space network more often than not. Commercial satellites, you know what, I really can't say what's typical. But for our mission, what I can say about our mission, are we going to rely on something like SatNogs for communication? Yeah, we will likely reach out to the SatNogs community and gauge interest from this, group of amateurs that are passionate and doing it for free. We'll also likely use the Kauai Community College ground station that HSFL has access to. So yeah, I don't think I can talk to what is exactly typical. Some requirements during the process of the spacecraft life cycle. In the manufacturing and assembly process, all of the communication components should be handled with ESD sensitive protocols. So working on ESD dissipative mats, just making sure you're careful when hooking things up. When it comes to testing, there are some tests that we have to do with the comm system to verify that they work. there's something called open air radio testing or link testing, where you have a transmitter and you have a receiver, and you have these attenuators to kind of mimic the attenuation of space or the atmosphere. And then you set them some distance apart and you try and send your signals. Then you have this computer that is in the loop that's observing the kind of signals that you're picking up to see if that signal was clear enough to distinguish what the original signal was. So you need the proper equipment for that. And then for deployment, you need to be aware of orbit tracking software and coordinate with JSPOC, which is the agency that tracks orbital objects. Okay, answered all the questions. So with the last 10 minutes, I'll just talk about general arrangements and design drivers.